So hello, and thank you to everyone that is joining in. Today we are welcoming two organizations to discuss some really impactful results with us all. So let me go ahead and give a quick introduction to what we'll be discussing on today's webinar. We're going to cover how 20 geographies are now able to better predict, detect, and respond to traffic incidents. So a quick introduction of the organizations presenting today. We have Waycare with us, who is a cloud-based platform that provides AI solutions for proactive traffic management. And then we have Wejo, who is a data exchange platform and the world leader in connected vehicle data. Today, we're going to share some insights on how, in partnering together, Waycare was able to gain heightened roadway coverage and improve incident detection while supporting agency collaboration with connected vehicle data. Before we get started, a quick introduction. I went over the introduction of the companies. I'm going to do a quick introduction of the speakers today, and then we'll dig into current challenges across transportation agencies, share our joint solution to those challenges, and review a case study before opening up for some live Q&A. So our speakers for today, we have Paul Zamsky, the head of strategic partnerships at Waycare. We have Alex Smoliak, the data science team lead at Waycare. We have Jim Eaton, AVP of solutions engineering at Wejo, and Joe Birch, AVP of channel partnerships at Wejo. Now, Paul, I'll hand it over to you to walk us through some of the core challenges that transportation agencies were facing before we deployed our joint solution.
Thank you, Casey. Well, really excited to be doing this webinar with Wejo and kind of going over some of the work we've been doing together over the last few months, even a couple of years now across the US. So I think where we want to start is look at kind of the issues that we've been running into in regards to what limitations typically agencies have in understanding what's going on the road and what is kind of impeding them for an improved communication and collaboration. A few different things that we've noticed initially when we kind of deployed was how siloed data and the systems are across the US. We have states, we have counties, we have cities. I'm in the poll here. States, counties, and cities, each with their own systems, a lot of times with their own law enforcement agencies and DOTs. And a lot of them are not communicating so that we cannot see actually when an incident is happening on one, what's happening down the line to the others. A second issue that we've also been mostly made aware of is the fact that when an incident is, to be able to actually have understanding of what's going on the road, we actually rely on physical infrastructure. So you need to actually have some installations to see what's happening, what type of roadways there are, the type of vehicles that are going on there, the counts, and so on and so on. And that's putting a situation where we need to actually focus on major corridors and arterials, and it's giving huge, patches of road where there's actually no visibility out there. On top of it, there's so much untapped data that's coming from these connected vehicles, which are now acting as virtual sensors on the road. So this is a really interesting source of data and a place to kind of explore. The last part is, when we're seeing that there's no actual infrastructure over there, we actually don't have that coverage. And that is a significant issue when we're talking about areas where you don't actually have information about incidents, you have no information about what's happening out there, and it's creating a big void that is affecting the actual response for a lot of agencies in that regard. If you want to talk really quick, I guess the next slide, we can talk a little bit about a good example of what the issues are within collaboration. So typically we see, the field users, the TMC users, and each, kind of have their main use case and the main kind of focus that they need to work on, which includes, understanding where the incident is, detecting that incident, and from there being able to actually respond to it as effectively as possible. There's significant impacts of having an incident out there for too long and with too many people on the ground, both risk for the users, risk for the drivers, impact both on the commute, on the congestion, on chances of secondary. And it's important to kind of have all these different organizations be able to communicate along, have a full visibility, and be able to kind of work together in that regard. So we really wanted to focus that as like a step one within some of this work out here. The second two is kind of looking at, what are the areas we talked about that are currently plaguing the infrastructure and the issues that we're running into. And Alex, maybe you want to talk a little bit about the limitations of some of these.
Yeah, sure. Happy to. Thanks, Paul. Hi, everybody. Happy to be here. So I'll give a few words about reliance on physical infrastructure, what it means for our customers and users, and what it means for us on the processing and data side. So on the one hand, just the outright installation of the infrastructure is relatively expensive and very labor intense. The additional kind of point to that is that after you've installed, it's pretty hard to maintain it, right? So whether the physical infrastructure relates to such things as loop detectors or Bluetooth sensors or cameras, those are all typically not very easily maintained or replaced. Specifically, of course, such heavy infrastructure as loop detectors that are, very informative and very useful. But if a pair goes out, there's a lot of work that needs to be done in order to replace it, with a lot of traffic interruptions, et cetera. The other thing that the various road sensors typically have is relatively high latency in terms of the time it takes from an event to take place to the information to get to us as data processors. So for one, there is the simple aggregation time, right? So we're not getting information per count or per impulse. We're actually waiting for the sensor to get a bunch of data aggregated, after which it sends the data over. The initial part of the aggregation can take anywhere between the 30 seconds as stated here, which is actually a very optimistic case, up to about 5 minutes. The typical time is somewhere between 1 and 2 minutes, but this is basically just the time where the sensor sits there and counts everything that happens on top of it. After that, there's the phase of getting the information across, which kind of depends on the provider, depends on connectivity, et cetera. And it's usually time that we don't have any control and very little information about. And then lastly, because of the cost and because of the convenience, these sensors typically tend to be stationed relatively far apart from each other, right? So you'd have kind of monotonous road segments between, say, an off-ramp and an on-ramp, where you'd have information, where you'd have like one sensor station, maybe you'd have a ramp sensor, and then for a few hundred feet, and sometimes even up to half a mile or a mile, you would have almost no information at all between various sensors, with this basically blindness. And that's, of course, not to mention such things as arterials and kind of surface roads, where people just typically don't invest in the infrastructure at all. Paul, do you want to take it from here?
Yeah, thank you, Alex. Thanks for laying the land on that. And I think the important part also is to then look at what is that impact? What does that actually translate into? Our primary goals here at Waycare is to reduce traffic fatalities and kind of improve mobility on the roadway. So we look at these metrics a lot and how we can kind of achieve these KPIs that we believe are useful both for the agencies as well as for the users out there. And one, significant impact that we see with slower incident detection and slower response includes, safety and congestion issues that are pretty significant. Every minute that an incident is actually still on the road, there's a 2.8% increase of chance for a secondary crash. So basically that every minute that we can get it off the road, we're kind of reducing that chances of secondary. And secondary crashes actually do have a strong tendency of being pretty fatal crashes. And we've been working a lot with the agencies and trying to see how we can mitigate those happening. But if we can get, first of all, slower response time, faster response time, slower incident faster response time, kind of slower time to kind of getting back to normal, it would be important to be able to get that back to normal. The second part of it is congestion. The impact of 1 minute of congestion equates to 4 minutes. 1 minute of an incident on the route, equates to 4 minutes of congestion. We really see this kind of, it takes a lot of time to get things back to normal when there is a significant disruptance out there. So what we're seeing is not just, an apples for apples. We're just seeing this big impact of every single action that is happening out there. And the last part that was really also of significant importance is how much we're focusing on urban roadways. Vision Zero is a good example where we're kind of having some incredible initiatives across the US, but they're focused on municipalities and roadways where there is a lot of already infrastructure. There's a lot of work to be done. We're not saying that not to be there, but we need to really look at also all the places where you have slower response times, where people might not fall in with that 1 hour, that golden hour to get to emergency services or the EMTs out there, and that are higher risk of fatalities or long-term injuries from these incidents. And because we don't have visibility out there, because we don't have data, incidents are detected slower, less incidents, and slower response time. So that's kind of a big part of what was driving us to push the envelope and how quickly we can help detect incidents. And this is kind of where the partnership with Wejo has become, a really crucial part in the work that we've been doing out there, because we've been able to really work with their incredible data sets and actually getting the assessment back to the users as quickly as possible. And maybe, from there, I can let Wejo talk a bit about their data.
Wonderful. Thank you, Paul and Alex. I'm going to go ahead and hand it over to Jim from Wejo to speak to how some connected vehicle data solutions can directly tackle these impacts of the challenges Paul and team have outlined. Jim, over to you.
Thanks, Casey, and thanks, guys. Thanks to the guys at Waycare for supporting us in this conversation today, and it's good to talk to the forum that we have. So let's look about this in terms of the key benefits of connected vehicle data. But I would ask you to think about some of the statements that Paul and Alex have both said through their parts of the presentation. So Alex was talking around in terms of the latency and some elements, and Paul was talking about the need for that real-time data. We'll touch on those points as we go through some of the slides that we have here. But to go through this section, then essentially, let's talk about the accuracy and the integrity of the data. So our data is directly from connected vehicles. That's essentially what Wejo is as a connected vehicle data vendor. What this means is we have highly precise data. So each one of our data points that's captured every 3 seconds from a vehicle is precise to around 6 decimal places of accuracy, of precision, should I say. The accuracy of which each data point has in relation to where the probe says it is to where the probe actually is around 3 meters. So why is that important? So let's think about that in terms of some of the use cases that we'll talk through in a little bit more detail as we go through today's presentation. But think about it in terms of if you need to know precisely where an incident may have occurred, where that tailback is ending, and where you need to do some mitigation of risk and involvement in that area, it's really critical that that data is providing you an accurate location of where to look for that problem. So that's one piece to consider. So then let's look at speed of visibility. So speed of visibility is something that is a key USP for Wejo, essentially, that we can provide our data from up to 11.3 million vehicles at current head count of a turnover of 60-second latency from capture to our prospective partner. So that is a quick turnaround in terms of that volume of data across the US road network. And again, I'm sure you can start to piece this together why that is important. So let's think about the piece that Alex was talking earlier in terms of the capture rate can vary depending on road sensors, the need to see it and identify an incident quite quickly through some of the stuff that Paul was talking about the slide before mine. So you start to get a picture here of why that real lightning fast data from Wejo can support in these use cases. Then let's talk about improved efficiency as well. So in terms of improved efficiency, you're not having a visibility on data just in those traditional areas of high, shall we say, road sensor coverage. So your closed loop data sources, your CCTV footage, etc., that a TMC might traditionally use, a traffic management center, should I say. Think about our data in terms of where the traffic is. We have a representation. So to talk to that representation, Wejo sees data on up to 95% of the total US road network. That's really important when you want to understand what the impacts of an incident may have on the remainder of your network. So for example, congestion on the interstate, where are people detouring to, into what residential areas, etc. So you can still see the information as it flows. We do not limit our data to a particular functional road class, in essence. So the final point that we talk about on this slide before we go into a little bit more detail about the data flow, we talk about innovation. So the innovation from Wejo essentially is we're just starting our journey, and there's a deliberate pun there. Wejo stands for We Journey. We're starting our journey here in essence of what connected vehicle data can do. We talked about it in summary on this slide of a quicker response, quicker data turnaround time, very, very precise across data across vast networks essentially, but also think about the other sensors and attributes that could come directly from a vehicle and how they could support various other use cases going forward. And that's a piece of that innovation. So if we move on to the next slide then, and we talk a little bit more about where our data comes from. So as I mentioned in the previous slide, we have data from 11.3 million vehicles there or thereabout, and that is growing by the day. And this data set is made up of data from various OEMs, and Wejo, and why Wejo exists essentially is that data vendor is bringing together those various data sources into a common data model for our onward partners, such as Waycare in this example. So there is two benefits to that, to our onward partners in essence, one being that providing a combined data set from OEMs that have a different take on connected vehicle data, let's say, and bringing it into that common data model so that it is more digestible for their onward platforms, etc. But the other element would be in terms of contracting is done with Wejo directly rather than having to source data from each individual OEM, which that's Wejo's part. That's what Wejo is ultimately in the business to support in. So let's look at this view here a little bit, and essentially I want to touch on a couple of other quick points while we're here. So there's a point that you can see on this slide around consent, and this is also really an important thing to draw our attention to for today's purposes as well. So consent actually is provided at point of purchase of the vehicle between the manufacturer and the owner of that vehicle. That then gives Wejo access to the vehicle movements, the journeys of that vehicle over a longer panel of time, a longer view of time. So let's say customer can, the purchaser of the vehicle signs to be on a platform to get additional benefit in kind, and then their data then is provided to Wejo for some of the purposes that we talk about today. That means we have a static panel of data over a much longer period of time. This isn't a data set that has opt-in, opt-out. So if you can imagine, some data sets may opt in on a trip where that particular navigation device is needed. That's different for Wejo. So Wejo is essentially providing data all the way through the day, through the AM and PM peak, from the same panel of vehicles that could be active at that time, in essence. So that's something to consider. What I'd also draw your attention to, what I can mention on the previous conversation, previous slide, should I say, 450 billion data points come through Wejo's Adept platform and turn that around in less than 60 seconds to our onward partners. And that is US-wide. That's our service level agreement for US-wide data. So with that, that gives you a little bit more of a background onto where our data comes from and how we turn it over to our onward partners. And I'm going to pass over to Joe now, who's going to talk to us a little bit more about the breakdown of that fleet, because that's another important thing to talk about from Wejo. Over to you, Joe.
Thanks, Jim, and hi, everybody. So here I'd like to talk to you a little bit about the demographic insights that could be obtained from the Wejo fleet. To be clear, this is not insight that's inferred, but it's directly obtained based on the information that we receive from our devices or our vehicles. So if we begin by looking at the different models of vehicles in our data set, you can see we have over 65 different models. Now, this attribute allows consumers of our data to infer further insight into who is using roadways at a particular time of day or week or year. And unlike other data sources, this means Wejo are able to be transparent in allowing data consumers to see the age of the vehicles as well. Again, this is a further demographic identifier, which gives additional insight into the users of the roadways. Moving on to the type of the vehicle, Wejo can once again provide unrivaled insight by breaking down the vehicles in the fleet by body type. Now, like any data set, Wejo's data has a bias to particular types of vehicle. As you can see here, there are certain types of vehicle, SUVs, pickups, sedans, where they make up the majority of our fleet. So what's interesting about that is when we look at this in comparison to US buying trends, there's a direct correlation. This means that the data is incredibly relevant and up to date for our users. Lastly, I'm going to touch upon fuel type. Wejo has the ability to determine the fuel type of a vehicle. Sorry, just moving that poll out of the way. And this offers new possibilities in terms of use cases and changes around infrastructure. So as we know, US buying trends are changing. Government agencies are moving towards electrification policies, and Wejo's data is at the forefront of providing insight into the shift from internal combustion engines to electronic vehicles. Now, as I said, like all data sets, the Wejo data does have a bias, but knowing what the bias is and being able to be transparent about that bias means that our consumers of our data can understand and work with it more easily. I'll hand back over to Paul now to explain how Waycare ingest and utilize the data.
Thank you, Joe. Yeah, this is great, and I think that one of the reasons we really like working with Wejo in general, the previous slide, is the quality of their data, and I think that has been one of the reasons why it's been kind of a good proof of concept that is now kind of expanded to across the US for the use cases that we're working with. And I think it's important to understand, how we can take this data that is, coming in real time and leveraging it for some of the use cases and workflows that are important for traffic management and traffic operations. What we want to understand when we look at the Waycare side, when we look at basically what's happening out down the roadways, are all the different data sources that can tell us in a holistic manner, pretty much, what is the current situation on the road, and how can we derive insights that can help the agency be proactive and see and know what to focus on. So taking data from existing infrastructure, so the existing historic data, incidents, the current sensors, but anything that's external also, weather, events, seasonality, construction, crowdsourced data, connected vehicle data from Wejo and other partners, and deriving that into creating insights that can be then used for detecting incidents from the moment they happen. So getting to that T0 as close as possible in the TIM's realm, to even shifting from a reactive to a proactive approach by predicting where crashes are going to happen, identifying the impact of incidents nearby. So when an incident is happening, where are the areas that are high likelihood of chances of secondary crashes, where the areas are going to be of significant impact on congestion following that incident. And the Wejo data has been giving us that ability to get as close as possible to sampling what's happening on the roadway by getting a bundle of data. And I think it's really important to understand when we talk about connected vehicle data here, we're not just talking about aggregated data, which is a good source to start working with, but aggregated data is going to give us limited visibility and more upstream view of what might be happening at the location of an incident. And short of having every single vehicle transmitting to us an airbag deployment every second, we want to use the vehicles near an incident to actually be able to detect when an incident is happening through contextual driving behavior, such as hard braking, swerving, and all that cool stuff. And I'm talking like, I'm the one taking the credit, but Alex and the team here have been really good at getting that done. But the important part is the more accurate and the richer the data and the faster the data is, the more we can optimize and take advantage of that for the use cases that we're working with. The data, once it becomes, after a few seconds, it's already becoming old. The value is losing it, and we really want to make sure that the agencies are able to capitalize this incredibly rich data we're able to work with over there. And Alex, maybe talk a little bit about some of the work and coverage that you saw and some examples.
Yeah, sure, Paul. So this is actually a very good example to kind of highlight the coverage that we're able to get from data provider such as Wejo. Specifically here, we're looking at Wejo data in the Salt Lake City area, right? So what we can see here is the coverage that we get and the penetration that we get on various types of streets, right? So the red color would show very, very high or very intense coverage, where we basically get a very high amount of vehicles per unit time. The yellow one would be relatively medium, and the green one is our locations where we do get some coverage, but it's not very intense. So as you can see, if on the typical kind of infrastructure-based information set, we're expected to get data only on the freeways, only on the major highways and trunks, then with Wejo and similar data providers, we're able to get very good coverage also on the main surface routes and arterials, to the extent that we're able to get visibility, which is completely equivalent to actually having physical sensors there, right? So we're able to get multiple vehicles per unit time. So I'm talking about, say, tens of cars per minute, give or take, for the more intense locations, which is basically a very reliable sample. It's a bit hard for me to estimate kind of the exact number, but we're estimating somewhere between 1 in 5 in the highest end and 1 in 20 cars on the street that we're able to get and detect and able to read and analyze. So based on all this information, we're able to cover almost the entire length of the city streets. So you can see here we're talking about almost 90% of the length. And I think that last we checked, it was around 98% of kind of the main roads and arterials. And that coverage is given to us basically once every 3 seconds, a bit of information flowing in. And on that on that ground, we're able to build relatively accurate or fairly accurate detections of kind of the behavior of traffic at any given time. We're able to understand whether or not something is taking place. So Paul, you want to talk about what we do with all that pretty information?
Yeah, no, 100%. And that's where, the ability to process the data and work with it, and the ability to get the rich type of data, I think really made kind of this interesting marriage for some of these solutions that we're creating. And the idea here is a lot of the agencies and a lot of people that I see actually on the attendee list have talked about us, about Wejo data. And I think we just said people have talked about them about Waycare. And I think this kind of makes sense in the way that we see that, the data needs that computing power to be processed. And we work with data that is, Wejo, the type of data that Wejo gets. And we're really excited on seeing this growth with additional vehicles and richer data, and even be able to kind of take it to the next level. The idea really is to get the traffic management centers to use this type of data and have it in the hands of the users without being completely overwhelmed with all these different sources, with all these different types of data sets. This is a incredibly valuable source of data to tap, an incredible use case of vehicles out there that can help not just understand traffic management, but start looking at smart work zone management, weather impact analysis, understanding how to work on multimodal optimization, and so on and so on. There's a lot more to kind of grow from this, and obviously the primary goal here is still traffic fatalities and traffic crashes, because we know where we stand today in the U.S. and kind of around the world. It's not good, and it's important to focus on that in the time being. But as we're moving along, there's a lot of really interesting solutions that are coming out over here. And we really want to make sure that this is something that the agencies can leverage to the fullest extent. And we're really excited to be deploying this with Wejo in partnership across many different target regions in the US. I think maybe, Alex, it would be good to kind of look a bit at, what does it mean working with this type of data? How does that actually translate into something that's, for the end user?
Yeah, sure. Thanks, Paul. So what we're going to see here, I'm going to walk you through a little bit before we actually dive in, is our ability to kind of leverage this data everywhere where we partner with Wejo or a data provider that gives us such high granularity and high volume of data. So basically, the trick here is to go from having a lot of information, which is great, but not always very useful, to having good insight, right? And the idea is to be able to process all this data in real time or near real time and be able to kind of understand what it is we're getting from it. So what we're going to look at right now in this video here is visualization of one of our algorithms detecting incidents, right? So we're going to look at a freeway in Austin, Texas, right, where the color kind of highlights the speed. You can see on the right the bar, and soon enough we're going to see one of the segments starting to go darker and go a little red, which is basically our algorithm detecting that something is not right there, and at some point it crosses a threshold. And when you see this kind of teal light up, is basically when we said that something is wrong, and from there you can see kind of the event spreading throughout. And only several minutes later do we see a social navigation app, the Waze, popping up a report that something actually happened. Like, what does it say? 8 minutes later, right? So roughly 8 minutes passed between the moment that we identified the event using connected vehicle data from Wejo until the time that the adjacent segment actually popped up an event that could go out to users that kind of are connected to the app. So the idea here is that we strive to give faster response times. We aim to give more accurate locations. When in the example you saw here, we're still working at segment level. We're now able to refine this to the low segment, or we're kind of finalizing this approach. But having granularity, as I mentioned before, the like 6-digit accuracy of lat long GPS, along with the 3-second resolution, is allowing us to have a very good idea about what's going on everywhere, both on freeways where information is relatively abundant but not necessarily very closely packed, to more kind of sparse roads where there's much less visibility from the existing sensors. So I think we can have a look at what it gives us overall. Next slide, please. Yeah. Okay. So this is one of the more recent kind of experimentations that we did, and the reason that we're going into that is because here we really went into, or relatively deep into, the numbers. And one of the things that so basically the 3 important parts here is that we're able to see more events, we're able to see the events faster, and when we do see them faster, as Paul mentioned earlier, we see them typically faster by quite a decent margin that, if translated into response times, would allow to clear events much faster and to kind of alleviate congestion, or kind of make sure congestion doesn't even set on. So to begin with, one of the very interesting figures here is that we note many more events that have taken place in addition to kind of the events that already make their way to the traffic management centers. The important thing, by the way, to mention here is that the point here is to kind of add information, right? We're not replacing. There's a lot of importance for people kind of phoning events in, both because information is not always available and because some additional accuracy could be gained from that. But there is a lot more information coming in through our systems. The other thing is that almost half the incidents that were detected by various calls or other information systems were detected earlier by us, right? So in these cases, the information actually does come in, but it comes in a little later. And this margin is, as you can see here, is almost 10 minutes, right? So this translates to a very significant margin in terms of the ability to respond and to both clear people who may require assistance in emergency response, and of course, as Paul mentioned earlier, to clear congestion. That's it, I think, for me.
Wonderful. Wonderful. Thank you, Alex. At this time, that concludes the majority of our presentation, and we'd love to open up an opportunity for some Q&A from the audience. So thank you, Paul, Alex, Joe, and Jim, for sharing. I'll go ahead and head over to the Q&A portion here. Let's see here. A question for you, Alex. What is the rate of penetration of CVs on the roadways to provide a reliable sample?
Right. So I think that the percentage is not necessarily as important as quantity, right? So percentage-wise, it kind of depends on where we're looking at. On freeways where there's very heavy traffic, a relatively small fragment of the vehicles, anywhere I think within the 2, 3, 5% would be amazing. When we're looking at more distant roads, then obviously, since there are less vehicles and we do need some sort of sampling, then we probably look for a little bit more than that. But that really depends on the application, right? So if the application is very short-term and very real-time, such as incident detection, then we'd be looking for higher penetration, and that'd be very important. If we're looking at something that takes a little longer to develop, such as congestion or such as longer-term traffic kind of modulation or pattern shifts, then we're able to work with a little less data and be able to kind of aggregate it over time and get to very good insight.
Great. Wonderful. Thank you. All right, let's go back to the questions. A question that could rely both on Waycare and Wejo to respond. Paul, I'll hand it to you to kick off, and then you can share with Jim and Joe if needed. What percentage of vehicles on the road are represented in the Waycare and Wejo data sets?
Sorry, guys, I'm mute. That's a good question, and again, it depends. It varies, from also we're looking at different types of data sets. So we're talking obviously the connected vehicle and so on. We're looking, between 5 to 15% of vehicles that can be represented out there. On top of it, we want to bring in additional sources. So we work with a lot of probe data and other crowdsourced data available out there. So even though we're showing the use case with Waze, Waze is a good example of some data that can then be used on top of that to actually help supplement in places where we might have some gaps out there. So the exact percentage that they're going to be transmitting to our system is depending on the variable. The actual amount that Wejo has, I'll let Wejo kind of answer that more accurately, but it's obviously a significant gap between different areas in the US where we have different types of vehicles.
Yeah, I can add some further clarity to it. It's echoing some of the statements from where Paul and Alex was talking essentially. So it's important to bear in mind that Wejo has a percentage of the fleet overall that's out there on the US road network. We mentioned it earlier on, around 11.3 million vehicles at current headcount, and that is growing year to year. When we look at the data at the sort of the more road segment level, we see a penetration rate around 3 to 5%, as Alex was talking about in some of his playthrough earlier on as well. And that is still of a statistical significance to model the overall volume of data in a given area. And why I say it in that way is an important thing to draw attention to. So currently, Wejo is seeing 1.1 billion journeys daily, thereabouts, from these connected vehicles. If you imagine the size of the data that's being produced from that and the load of data being provided onto onward customers, I guess the thought point there is, when is enough, essentially? So is it better to have a percentage that's usable, or try and wield the entire 50%, 70% of the total US road network? That's something to consider. Where we are already, we have a statistical significance. These numbers will grow in volumes. We are projected to see in the US this year hit around 13 million vehicles total. But that's something to consider. Where is the delta between where it's enough to give you insight, or is it too much to handle, I guess? And that could be another thought point to consider in respect to that.
Great. Thank you to both Paul and Jim on that. Another question, let's see, from an Anthony. Your data appears to be biased toward wealthier segments of the population who have means to purchase new vehicles. What steps do you take to mitigate this bias based on your data?
I think that's a very, very good point, very good question. And I think the key thing in this is one of the points that Jo mentioned in part of her playthrough as well, that we can be transparent about what the bias ultimately is. So if you compare us to other data sources that would be in the LBS location-based services realm, it is unclear what form of transport that vehicle may well be in. With Wejo, we're telling you exactly that it's a privately owned passenger vehicle, down to the year of the vehicle as well. So I think it was to your point as well, Paul, earlier, that it is a combination of various data sets in this world that can provide a further insight of the overall. But with Wejo's data set, essentially, you can model traffic directly from vehicles rather than, how can I put it, the correlation between a data capture method and the amount of occupants in the vehicle that may skew a count in some instances. So we have that kind of slant in our bias, essentially. We still stand by our coverage of up to 98% of the interstate roads and 95% of the total US road network, even with the bias that we have now. So we are giving you a probe in the mix of every roadway to give you some understanding of what speeds look like in that given area, or what the condition of traffic looks like in that area. So yes, there is a bias still to modern vehicles. That will play out over time as we get, guess what? Connected vehicle data isn't going to go away. In fact, it actually is going to become a greater and greater part of this ecosystem, essentially. But also consider that we already have an element of probes in the mix to give you an indication of what a typical roadway may look like across all functional road class.
And let me jump on that also to add additional, Jim, and thank you for that feedback on that. There is obviously, newer vehicles. I mean, newer vehicles is also 2015, 2016 is when we're starting to see some sort of connectivity to them. Obviously, what we want to make sure is that there is coverage across all the different socioeconomic, and demographic areas around the US. The interesting part of it is that you don't actually need to have every single vehicle out there. So not everybody needs to have the most updated vehicle to be able to actually transmit and know. So in places where we see more economic, poor areas, typically, we'd still have significant coverage. And actually, from anecdotal view, we do have more than certain more richer areas that might actually have some vehicles that are a bit more unique, let's just per se, in more kind of niche markets, because of the fact that there is a lot out there. There's a lot of philosophy also to go over about the leasing of vehicles and how, you know, that's being used for, you know, providing people with newer vehicles in different areas, but that's a different kind of discussion. I would not, you know, kind of venture down the path over here, but I'd be happy to, you know, to show in places where we are deployed out there that we actually have good coverage in places, not just based on the wealth of the population out there. We can just get a few vehicles. That's enough to be able to get us the full road view of what's happening out there. And that's a great question.
Wonderful. Thanks for elaborating, both Jim and Paul. 2 questions for the Waycare team. So Paul or Alex, we'll keep you going. Where is Waycare? The question is, where is Waycare currently in use? But maybe speak to where Waycare does business overall at this stage.
Yeah, so Waycare, we are deployed in about 10 states across the US, from California to Texas to Ohio, Missouri, Florida, North Carolina, and I can go on and on. We are really excited to be launching a lot of new projects across the US every few weeks and months, and working with a lot of partners out there to get these up in place. We are also currently live in Israel, which is our headquarters. We have a lot of work going on over there, and we're about to kick off our 2 latest projects, one in Thailand, Southeast Asia, as well as in Sweden, as our first kind of EU based project that we're going to be launching hopefully in the next few weeks. That's on the Waycare side of things.
Great. And continuing for Waycare, how do you integrate other outside data sources into your platform?
So we start with looking at the data on a historic level. So we always want to start getting this significant amount of data to start building the model. So each model is kind of based on the specific roadway. So Vegas is different than Raleigh, which is different than Austin, Texas, obviously. And the goal here is to make sure that we take as much historical data at first and ingest it as part of the model for the training. The second part of it is to get as many feeds as possible from CCTV to DMS boards to the existing ATMS systems, and we work with the agencies and those partners to actually be able to get a feed directly from their system to ours, both of existing sensors that might be out there, as well as the ability to actually push information back to the existing infrastructure. The idea is that there's already a lot of software in place out there that are being used by the different agencies, and what we want to make sure is whatever we're able to deliver outwards out of output can actually be used outwards to anybody who's out there. So we're integrating with a lot of the ATMS providers to actually get this data flowing back and forth between our systems.
Great. Wonderful. Okay, so I think we've got time for a couple more questions. Let me see how many more we can get through. So going back to the incident detection or congestion identification slide, are you able to calculate the speed and flow and curve and accurately detect or identify flow breakdown point?
I think that one's for me. So a few words on that. So yeah, we are able to calculate the flow relatively well. We're able to calculate the breakpoint, the breakdown point, to the extent where it's more or less repeatable, right? So obviously, when you look at over enough time and over enough conditions, it kind of, at least to some extent, generates noise, right? So the nice kind of triangular models or hyperbolic or parabolic models that are often used in theoretical analyses are a very distant approximation, but unfortunately, reality doesn't always work out like that. So we are able to get that information to some extent in order to be able to understand what's going on, maybe how roads differ and where they're able to kind of where they're able to support more or less traffic. We are actually working on utilizing this information, kind of further analysis and further models that we want to develop, where we're able to kind of plan and suggest various activities on the road in order to kind of maximize utilization. I hope that covers it more or less.
Great, thank you. Thank you. Okay, a couple more. let's see. This is for the Wejo side with some weigh-in from Waycare. What is Wejo's data latency from the connected vehicle to the operator at the traffic management center?
Cool. I guess we'll do our part first and then hand over for the handover in between that. So as we mentioned in some of the presentation today, we have a capture rate of every 3 seconds, and the latency of every single data point that we capture every 3 seconds has a sub 60-second latency as an SLA. Typically up to the 95th percentile of our data, we can actually turn it around in around about 30 seconds. But that is from data capture in the vehicle through our internal processing, and then getting that in a position to then pass on to our onward partner being Waycare. So I guess it's on to you guys then for the next piece and what that latency can look like.
Yeah, so I'll give a few words on that, and then Paul, if you want to add something, please go ahead. So again, here it kind of depends on what it is we're doing with the information. Since our goal for most of the time is not to kind of just spit out the raw data that we're getting from Wejo, because it might easily overwhelm the users on the other side just because of the sheer quantities. What we typically try and do is get the insight from the data, and there are various latencies involved. So the shortest ones would be of the order of a minute or two on top of what Wejo provide us, right? So we kind of aggregate a little bit of information internally in order to be able to understand that something interesting is happening, such as the neat little video you saw previously on detecting an incident. Some of them may be a little slower, such as, for example, detecting congestion that's building up. So you wouldn't want to kind of jump to the conclusion that something's wrong based on just a few samples. You really need to understand that patterns are changing, or the patterns are conversely conforming to what they need to be. And lastly, there are kind of longer processes that involve analysis that is virtually offline, and though in that sense, of course, the latency doesn't really matter, but the information eventually makes its way to the users in the form of reports and intelligence, kind of an analysis, in-depth analysis of the data, also based on this information source.
Great, thank you. Okay, I think we have time for one more question. Let's go out with a bang. All right, so can you explain how crash prediction is accomplished? How do you measure accuracy around that as well?
Yeah, sure. I'll give a few words about that as well. So crash prediction is actually one of the algorithms that utilizes, I think, most of the data we consume. It uses both real-time speeds, it uses historical crash data, historical speeds, it uses weather patterns, special events, etc. And based on all that, we try to kind of identify risky segments that are either risky compared to other locations or risky in comparison to themselves previously. The accuracy here is really kind of tricky. I won't go into the mathematical details too much because it's probably not that interesting to the forum, but luckily for all of us, incidents are relatively rare or very rare. So measuring accuracy of rare events is a very non-trivial kind of problem. There are a few kind of textbook solutions of kind of only looking at the quote unquote positive event, which in this case, of course, is not positive in the good sense, just positive in the sense that something happened, and ignoring kind of the entire bulk of time that nothing happens. In that case, we kind of look at the amount of crashes we detect versus the amount of crashes we miss, or versus our false alarms. There are also some mathematical metrics that kind of incorporate all that into a single number that once you get accustomed to is relatively easy to understand. So for us, kind of understanding that we don't raise too much noise to the users and we don't miss more than we are reasonably allowed to of what actually takes place is our main approach to accuracy. I think that's my take.
Wonderful. Wonderful. Well, thank you. With that note, we've just about run out of time for today. There are a couple of questions that I will answer in type response, so that those are in the Q&A session for those looking to have their questions answered as well. If we couldn't get to you, apologies for running out of time. And thank you to Paul, Alex, Jim, and Joe for sharing your insights today. It was really great to hear from you all.